So first with Stategraph, where are we today? So we have defined a database schema for Terraform state files in OpenTofu, of course. The overlap is quite large there, of course. And we have functionality around importing your state files into the Stategraph database. And now that your state is in a structured format inside the database, you can perform queries on it. And when I say putting into the database, I do mean that there's different tables for different elements of the state file. It's not how the Postgres backend does it in Terraform now, which is just a big JSON blob. This is actually structured. And for a reminder of the goals of Stategraph, we want to provide insights into your infrastructure. Right now, we're focusing very much on state, giving a structured representation of it, giving the ability to query information about it, both in what it is now, but also over time. And then we also want to make plans and applies super fast. We don't think that you should have to break up your root module just because Terraform can't handle the size of it. The problem here is that once you have a very large state file in Terraform, it treats it as one massive blob. And so it has to operate on it as one atomic unit. But as we know that your state is actually more of a graph, it has individual resources in it that can be individually operated on. So if each one of these colors represents a change that a user wants to perform inside of their infrastructure, these don't overlap at all. So all three of these should be able to operate in parallel without blocking each other, without serializing on the state. And that is what Stategraph wants to accomplish there, to enable you to perform operations that are independent in parallel instead of treating the state as a massive blob. So we have a timeline on how we think things will go. A lot of this actually really depends on your feedback, what turns out to be important to you. And so this is somewhat tentative, but it is stuff that we think is realistic to hit and we think actually provides real meaningful value. So at the end of this year, we expect to ship with Stategraph an asset management tool. So we have this representation of state, we have a way to get it into the database, and we have queries we can perform on it that give you information about it. And then we can also express that state over time, which is really powerful for understanding what's in your infrastructure and the assets that you have in management. We also wanted to develop a state backend. This will just be the HTTP backend in reality that uses Stategraph as the backend. So you automatically get all of that information into Stategraph in real time as you're performing changes. And you can also add metadata to it, like who's performing that change, what pull request it came in under, or anything actually that you want. There's any you can add any tags to that data that you want. So you can go back, oh, this is when this resource was made. It came in this pull request. I'll go back to the code to see what happened there, so on. And asset management is really, it's kind of like a functionality that needs to happen to get to where we want to go because we need to understand the state so deeply. So it just makes sense for that to be there. Now looking into next year with Q1 and Q2, in Q1, we want to support plan and apply, as we talked about, using this information that we have from the state in order to perform parallel operations safely. That's the big push for Q1. And once we're in this place where we can perform plan and applies on the subgraph with all the functionality we developed here, we're not quite sure if this is what everyone, what the future direction should be, but we do have the functionality and the ability to ship more of a Terraform control plane. So you have tools like Crossplane that provide this reconciliation loop, a really pull-based workflow. And they're very powerful, and you can use Terraform inside of them. But it's also, it's its own world. It's Kubernetes. You have to migrate your infrastructure to it. But with Stategraph, you can get all that functionality and that just seamlessly works with your existing Terraform setup. So we think that is really Not everyone wants this, but a lot of people want it, and it's probably where we're going to be going in the long run, just as an industry. Like it's just such a powerful model to work with. So today's demo, I want to show you importing a state into Stategraph. We've built some testing interfaces just to demonstrate this. Then we're also going to show that you can query the database directly. Now that we have this information in here, we can show you what the schema looks like, and then validate that we can actually query the subgraph given a resource that's changed. So let me switch over to that. So here on my, oh, a little bit slow. Here on my machine, I have just a main.tf. It's pretty simple. It constructs a DynamoDB. It has some EC2 roles. There's some connection there. For example, the DynamoDB policy references the DynamoDB main, and then also the EC2 role. So you can see there's a little interconnection there. And we also have the state file. Yes, I3. That has been applied given this. And so this is just a state file that Terraform output. So Stategraph is designed to be multi-tenant from the beginning. So you can have multiple tenants, and each one of those tenants can have as many states as they want inside of it. So in this interface, we will create a tenant. And then we will import our state file into it. Now, Josh actually developed this today, just showing off the functionality we have of being in a database. So it's a little, this isn't what the product will look like in the end, most likely, but you can already see that you can get a lot just from having access to the database here. So we can see all of the resources that we have and the dependencies information about them. You can also see that if we were to modify EC2 role, all of these other resources would have to be modified with it. So we know the subgraph necessary for modifying this. You can also perform some simple queries. These are the different types of resources and their counts. You can also see resources that have and how many dependencies they have for all those that have more than one. You can also see a representation of visualization of the graph here. And a few other things just showing off the functionality. Now, also really quickly, I want to show you. So this is what the schema looks like currently. You can see we have states, resources, providers, instances, as well as outputs. So if we want to see some outputs here, you can see we've also stored all the outputs so they can be queried as well in the database. You know, all this at your fingertips with some SQL. So that's all I want to show off right now. We've been grinding pretty hard at this, working long hours to make this possible, but we're really happy with the progress we're making. Now I guess I switch over to the room. Does anyone have any comments, any thoughts, any questions? Question from Austin, perhaps dumb question, but will there be any limitation due to provider usage initially? Azure, GitHub, AWS? Nope, there will not. So we're actually At this point, we're just working on the state level, so we're really providing a visualization there. But for the future, where we're going to do plan and applies, we are just using Terraform or Tofu underneath to actuate the changes to your infrastructure. So all of what you currently have will just work. Khan or Can, sorry if I mispronounced that. You're up next.
Hello. Right. So, I mean, this is great. This is exactly what I wanted. However, I have a question about the amount of text that can be imported. I just checked and I have about 300 Terraform states that I would want to import. Will there be any pathways to actually making that easier?
Yeah, absolutely. So the interface, as I showed you here, as long as you can do a state pull and then use the Stategraph CLI to tell it where that state is and import it, that'll just work. Additionally, if you do want to use Stategraph as your Terraform state backend, then you would automatically just get all of those input as you decide to migrate them over. Does that answer your question? Great. Yep, go ahead, Matthias.
Hey, Ozzy here. I'll actually ask a question. I just asked Matthias to raise a hand for me.
Yeah.
This meeting room doesn't seem to allow that. So what you just showed looks great. So nice work. I specifically wanted to ask, so we have quite a lot of resources split across several states. Some of that is because we want to have that separation. Some of them it's because, we just have to, otherwise Terraform will take hours. So I wanted to see, one, if you did any sort of, benchmarking, or if you have any expectations on, how large a state or how deep a dependency chain do you think this thing will support, in what sort of time? And also, if we do want to have several states that have dependencies on each other, which we currently manage with TerraGrant, is that something, do you think that your tool will be addressing, or do you expect that it will be used in conjunction with another tool like TerraGrant?
So for the first question, in terms of size, the test that I've been doing, I did a 50 meg state file that imported in around 3 seconds. That was in the order of, I think, like 20,000 resources or something like that. So I expect this to scale pretty well. And once it's in the database, it's actually much easier to work with because you don't have to load up like a massive JSON blob just to look at one resource. So, and we're using Postgres on the back end. So I expect it to scale quite well in terms of total size of resources. When it comes to depth, we're still doing some testing on that. All the state files I've thrown at it have worked in, like a pretty like humanly acceptable time, like in the order of like under 5 seconds for any query I've done. And I've also been doing more pathological queries rather than ones that I think actually represent what a human would do. So again, on that front, I expect it to scale quite well. So everything's looking pretty good there. Now, in terms of, will this work with TerraGrunt or something else? So yes, in the sense that the initial goal here is to be a drop-in replacement. So if you are using TerraGrunt, you can just drop Stategraph in and it'll do the thing as you expect it to. However, there is a larger vision there of one, not needing something like TerraGrunt at all, and being able to just have all of your state into the equivalent of a single root module. You can certainly split it out if that makes sense for you. But as everything's in the database, you can do references across different states, as every state has a unique ID. Additionally, if you do want to have multiple root modules, there's cool functionality Stategraph lets you have in terms of you can give each root module like the equivalent of an API key, and then say, okay, with this API key, they can access this remote state, but only the outputs, for example. We want to mask everything. They can only see outputs. And that way you know that there's no way for secrets to leak through with like a remote state data source or anything like that. So there's all this functionality that we're seeing that will work with that. So I hope that answers your question.
It does. That's great. Thanks.
Yeah, you're welcome.
Malcolm, the next question was written in the queue from Simon. So I'm trying to do it in order of getting the questions.
Thank you. Let me just scroll. Question is from Simon. Do you think there's a way also to see dependencies between stacks? Yes, we haven't implemented that yet, as we've been focusing on just getting a single state in there and making all that work together. But absolutely, that information is really encoded in, well, it depends on how you want to express that. But if you're using a remote data source, then we understand enough HCL to make that connection. So definitely dependencies across stacks.
And
next question.
Austin's question was right below.
Well, I think that was the first one. We have Thomas.
Oh, no, he asked another one. So I assume all state files can be migrated, no issues with CDKTF based projects?
Yeah, Austin, yeah, yes. Since we are operating at the state level and even with CDKTF, it's still Terraform underneath performing the actuation there, then all that'll just work because it's just the same state representation. Definitely, I think there's functionality that is going to be focused on the HCL side of it, but CDKTF does generate HCL with some metadata there. So I think there's opportunity there to connect all those dots on the back end.
Okay, and then it's Eduardo. Do you want to give your question? Eduardo Reyes.
Hey, this looks really good. So my question is related to the actual service. So Stategraph is a database, and I assume there's going to be some kind of HTTP process, right? Since it's an HTTP backend. Who owns that? Is there going to be the ability for us to host it ourselves?
Absolutely. Self-hosting is actually really important to us as a company. A lot of our engineering actually goes towards best serving people want to self-host. We do offer SaaS, but we see in the people we've talked to, like many people in this room, self-hosting has been really important to them. So the product is being designed from the beginning to be very self-hostable.
All right. Yeah, that answers my follow-up question, which was about data residency. So if you can self-host it, you can figure that out.
Yeah, I mean, we definitely in our Terra Team product, which is a tacos, we've actually shied away from doing state management at all because we understand how important it is to people and they want control over where that data is. And Stategraph represents us shifting in conceptually into understanding that in like having the ability to be very expressive and do a lot with state now. And that's one reason that it is a separate product, is because we do want to separate these things out, but obviously work together if they if you want to. But like we think state is something that is very important to people to have a lot of control over. So we wanted you to self-host if you want, or be able to store that information wherever is important to you, because there are secrets in there, of course.
Yeah.
Cool.
Okay. No, that's awesome. Thank you.
Great, thank you.
Malcolm Chan had another question in the chat. And
Is
then
this the four tenants?
Yes.
Four tenant concept, does it map one-to-one with the stack concept of TerraGrunt, or is it something different? Also, how clear is it when it comes to inter-tenant dependencies? So tenants I would think of as more of either teams or organizations, like in the GitHub sense. They are really a unit that you're going to want to administer all of this on. So like a tenant would have an administrator or a set of administrators, and then a series of states underneath. I expect if you're self-hosting, then you'll probably only have one tenant, and then you'll be managing ACLs around all of your states that way. It's really more if you are an organization, or like if you're like us, where you want to run a SaaS for this as well, or maybe you want to like white label this out or something like that, that you want multiple tenants there.
Okay.
Also for inter-tenant dependencies, unclear right now if you can have inter-tenant dependencies. Certainly it's all just data in the database, but we've been thinking about it more as like a tenant is like a sealed off concept. Is Peter next?
Yep,
Uh,
Peter's question next.
Yep. Do you see separated routes as the best way to deal with permissioning? We currently use separate routes to deal with team level access control. It would be a bummer to have a graph like this and still plan each route independently. No, explicitly, we actually don't think having multiple root modules is how you should be managing your infrastructure. You kind of don't have a choice right now because Terraform and Tofu fall over once your root modules get too big. But the core belief around Stategraph is that you should be able to manage access control at a resource level. And like conceptually, the entire world should be able to have all of their resources in a single root module, and with proper ACLs, like, you know, Apple and Facebook would never actually be able to mess with or modify each other's resources, even though they're in functionally the same root module. So like that's sort of like the conceptual vision of Stategraph.
Can I ask a follow-up on that one, actually?
Absolutely.
What do you like? How do you deal with a given permission level for like, because there's secrets all over the Terraform state that can't be shared, sort of thing. Like, how would you see that looking? Would you have to actually put ACLs on every resource and assign that like alongside that state graph? Or
So one of the things with Stategraph is that we actually understand HCL. So for example, you could assign an HCL at like a file level, and then that information actually makes it to the back end of Stategraph. And so you can use like regular expressions or something like that. So one thing I would love to see in the future is like in Tofu or Terraform, some way to add like your own metadata bespoke blocks to blocks. So you could say, okay, this is part of that, but we're not there yet. But so it'll have to be metadata outside of your actual Terraform code, but we will have rich understanding of your Terraform code so that you can then take that into like the UI and say like, okay, all these are actually owned by this team or something like that.
right,
Or you can enforce like a naming scheme that has to be like, team name, whatever. And if something doesn't do that, then it gets denied.
okay, cool.
Okay, one more question from Sean, and then we'll start wrapping up. But yeah.
Do you plan to have a Terraform provider for Stategraph to manage ACLs, Etsy via Terraform itself? We're getting pretty meta here, but yeah, certainly. So the unit of authorization identity is going to be an API key. So, and Stategraph is very it's API first. So yeah, absolutely. You can anything you can do as a human clicking around a UI or via the CLI, you can do via an actual API call, which means we can create Terraform providers for managing all that.
Okay, really quickly, if you look in the lower right-hand screen, there should be a blue dot, and you can click into the poll that Josh just launched. We're trying to just get a little bit of feedback from the group. So if you could fill out which feature is more important for your business and for your use case. While we're doing that, Malcolm, do you want to answer Eduardo? And then after we get the polls back, we'll wrap.
Yep. So I was going to ask if there's planned support for ABAC, and it would be awesome if the trust can be set with OIDC, as in this repository and branch have access to only non-sensitive. Yeah, that's definitely on the roadmap. Don't know exactly how all that's going to fit in, but yeah. So with like we're heavy users of OIDC in our tacos product, so obviously we want to bring all of that security functionality forward with Stategraph as well.
Amazing. All right. Looks like we got one more question before we drop off. Is there one more question? Eduardo, did you have one? Oh no, he was clapping. Oh, sorry.
Thank you.
All right. Well, really quickly, everyone, we are looking to double down with a few teams as design partners. If this functionality already looks interesting to your business to start getting value out of it, please let us know and we can engage with you to start working earlier on in the process. We are going to be launching, per Malcolm's point, more functionality in December and in early Q1. And we will be coming out with a paid product very soon. So if you guys have feedback or want to get more involved, let us know. If you want to keep being passively involved, the next opportunity will be December 15th or 18th when we have our next demo day. Okay? Awesome. Thank you all for participating and the feedback. We're very excited about this. And yeah, we'll be in touch.
Thank you.
Thanks a lot. Bye-bye.
Thank you.